Aloha, my name is Blair Langston. I'm the coordinator for Teaching Change. Today we're going to be talking about phenology, climate change, and Hawaii. So before we really dive in deep, I always like to think about why is it important to care for the environment? Why is it important to learn about climate change and environmental threats? And I always think of two reasons. Intrinsic reasons, one being that intrinsically we care for nature. We enjoy being outside. We enjoy seeing native species. We enjoy spending time with animals and being in nature. Um, so that's what I mean by intrinsic values. We personally care for and enjoy our environment. And then the second reason is that practically we depend on the environment to survive. We depend on these ecosystem services that provide us clean air and water to drink and food to eat and shelter. Um, so that's what I mean by ecosystem services. We depend on the environment to provide those to us. And it's important to preserve and sustain that in order for us to continue to survive. So with that in mind, we're going to continue. And first, going back to the development of the Hawaiian Islands. How did we start? How did we get here? Um, so as you may know, our islands were born from undersea volcanoes as the tectonic plates moved and lava came up from a hot spot underneath. Um, The lava continued to build upon itself until it reached the surface of the ocean and our islands were born. And over many hundreds of thousands of years, plants and animals began to arrive on the islands. And then after that, we saw the very first Hawaiians from our other Polynesian islands, and then followed by Europeans, and then more until where we are today. And the reason it's important to think about this is because this helps us think about how we categorize the current plants and animals that live here. So how did the first native plants and animals arrive in Hawaii that are now referred to as native species? Well, we saw three different natural phenomena bring our native plants and animals here. The three M's or the three W's. So moana or waves, makani or wind, manu or wings. So if a plant or animal arrived to Hawaii via these three mechanisms, they are considered a native species. Or then consequently, if you're born on Hawaii, you are considered native to Hawaii. If a plant or animal is brought to Hawaii by humans, by boat, plane, they are considered non-native. So this is just important terminology for us to learn when we are thinking about environmental protection. So those plants and animal species that came to Hawaii from the three M's or the three W's, those are our native species. And then there are two words that we can use to describe our native species: endemic and indigenous. So indigenous is analogous to native. It's another word we use to say native. It means you are from a place, you were born there, or you arrived there from wings, water, and waves. So indigenous is analogous to native. And then there is this word endemic. So endemic means you are native to a place, you are from that place, but it also means that you are unique to that place, that you occur nowhere else in the world. So nene goose are native to Hawaii. They are from here, or they arrived here by wings, right? But they're also endemic to Hawaii. So they occur nowhere else in the world. They are unique to this place, and they live nowhere else. A few more native endemics: ʻōhiʻa and mamaki. So mamaki, that's what we use to make our mamaki tea, right? You've probably seen that. ʻōhiʻa is endangered. It's a little more rare. So these plants are native endemic. Um, they only occur in Hawaii. They're found nowhere else in the world. ʻōhiʻa is a native endemic, and so is nene. Indigenous species native to Hawaii, also found elsewhere in the world. Ko, that's, you can see those pretty orange flowers we use to make lei. And then also naupaka. Naupaka is also found in Florida. So these are native, but they're not endemic. Indigenous species. A few more natives, haha and koa. The reason I'm bringing up the United States Endangered Species Act is because I don't want the terms endangered or threatened to become analogous or confused with native or endemic. So endangered means a species is considered to be facing a very high risk of extinction in the wild. And threatened means a species is likely to become endangered within the foreseeable future. So while there are threats to our native and endemic species, it doesn't always mean that they are endangered or threatened. For example, ʻōhiʻa is a native endemic, and it's not endangered or considered threatened by the Endangered Species Act at this point in time. So we also have non-native species. And then we can categorize these into 3 different types. So invasive, non-invasive, and canoe. So invasive non-native species they're the greedy species. They take up a lot of resources. They hog water, they hog sunlight, and all of those resources that other plants need to survive, including space. So when you think of invasive species, think fountain grass, that grass you see on the way to Kona that's taking over everywhere and leaving no room for other plants to grow. That's invasive. It's very aggressive. Non-invasive, we have a lot of non-invasive, non-native species here in Hawaii. You can think of like avocado or mango, eucalyptus. They're not native, but they don't have invasive qualities. And then we have our canoe plants that were brought here by the first Hawaiians. So they're non-native, they're not invasive, but they were brought here by humans. So things like kalo, ulu, uala, those type of plants. So non-native, non-invasive, like eucalyptus. Our invasive plants, Coster's curse, you've probably seen that hiking. Strawberry guava, Himalayan raspberry, Himalayan ginger. I see this all the time, invasive gingers. I just saw some hiking down at Volcano National Park the other day. And then our canoe crops, right? So these guys aren't invasive. Our sweet potato, breadfruit, we can grow them without them taking off and taking over. So review, we have non-native and native species. Our non-native consist of invasive plants that overgrow and act aggressive. They take up a lot of water. They compete native species out. And then our non-invasive species like eucalyptus and avocado that were brought here by humans, but they don't have invasive qualities. And then our canoe crops like kalo or breadfruit and sweet potato. And then our native plants. Indigenous means the same thing as native. It is from that place. It arrived via the 3 M's or the 3 W's. And endemic means it is unique to that place and it exists nowhere else in the world. So that brings me to a discussion about environmental changes. We can talk about environmental changes from a natural and anthropogenic standpoint. So natural meaning coming from Mother Earth, natural occurrences such as wind, rain, lava flows, clouds, earthquakes, tornadoes, all of those are natural occurrences, right? And then anthropogenic meaning man-made, or occurrences or changes in the environment caused by humans. So agriculture, buildings, things of that nature. So on this slide, the picture of the lava on the left is a natural occurrence that may cause harm to humans and the environment. And on the right is an anthropogenic phenomenon. Our agriculture, this is loʻikalo, a form of place-based agriculture in Hawaii. And while that's an anthropogenic change in the environment, it's not necessarily harmful. It's operating in synergy with its surroundings. Okay, so let's talk about changes that can harm the environment. Let's talk about some environmental threats that our native species face today. So a few we've mentioned already, invasive species. So we have mongoose. They're a threat to our native birds. They like to eat their eggs. Same thing with mosquitoes are a very big threat to our native birds. They transfer avian malaria. And with the arrival of mosquitoes, we've seen a very big decrease in our native bird population. And we have our invasive plants as well that outcompete space for our native plants. Our deforestation, development, loss of habitat. This is threatening for several reasons. First of all, just removing habitat for our native species to live in. They become displaced, don't have anywhere to live. That might increase chances, like this little turtle here. It's increasing their chance to get in harm's way. And then also with deforestation, when you remove trees, forests are a carbon sink. So as we know, trees breathe in carbon dioxide and breathe out oxygen. So we're interfering with that cycle, and we're increasing the ability for carbon dioxide to get into our atmosphere and warm the earth, which we'll talk about a little bit more. And then we have pollution as well. So putting pollutants into the environment, whether it's wastewater, sewage water, chemicals, air pollution from industry, that can directly poison the environment and poison our native species and ourselves. Another threat that we didn't talk about on the last slide is climate change. And before we get into that, we should really know what the definition of climate is and make sure we don't confuse it with weather. So how is climate different than weather? So climate is the weather conditions prevailing in an area over a long period of time. So for example, in Hawaii, we would say our climate is tropical. Tropical meaning is warm and it's wet, right? So here in Hawaii, we would have a different wardrobe than, say, if we lived in Alaska, where the climate is very cold and snowy and icy. But on a day-to-day basis, our weather might change. So just because it's warm and wet on average all the time here in Hawaii doesn't mean everywhere in Hawaii is that way all the time, right? So in Hilo, it's wetter. We have a little bit different climate than over in Kona, where it's drier. And on the top of Mauna Kea, it's colder. And just because Hilo is rainier on average than Kona doesn't mean that it's raining every day. So we still have some dry, hot days like Kona gets. So that's our weather, our conditions at a place at a time that day, compared to climate, which is the average conditions over a period of time. So climate tells you what clothes to buy for the whole year, even for when the seasons change, and weather tells you which clothes to wear for the day. Do you need your raincoat? Do you need a t-shirt, shorts or pants, etc.? So what does it mean when our climate changes? If our weather can change daily, how often does our climate change? Or does it change? And what are the implications of that? So the answer is yes, our climate does change, and it has been changing for a long time. And there are natural causes for why our climate shifts and changes. And one of the first reasons is the position and the stance of the Earth in its orbit. So if we look at the eccentricity of the Earth, sometimes the Earth might be orbiting a little closer to the sun, and sometimes it might be orbiting a little farther than the sun. So depending on this, what it's called eccentricity, how close the Earth is to the sun, it's going to change our climate, right? Because if we get closer, it's going to be warmer. If we get further away, it's going to be a little colder. It's going to change our overall climate. The overall climate of the Earth will be colder if we move a centimeter further away from the sun, right? And then we have what's called tilt, which is pretty straightforward. So the Earth has this imaginary axis that runs through the north to south, and that tilt might shift to the left and it might shift to the right. And depending on that shift in the tilt, different hemispheres will get closer or further away from the Earth, and that will change our climate as well. So if the southern hemisphere is tilting closer to the Earth, the climate's going to be warmer. And if the northern hemisphere is shifting further away from the sun, it's going to get warmer, right? But then we have precession, because the axis doesn't just tilt left to right, it tilts 3D, so it kind of wobbles on its axis, right? And that's going to change how close or far away the Earth is to the sun, and that's going to change our climate. So as a result of this, we have seen changes over time, natural changes. For example, the Ice Age. And we can see this, we can see evidence of this today physically. For example, Lake Waiau on the top of Mauna Kea is the result of a glacier melting on top of Mauna Kea after the Ice Age. And then there are man-made causes. So the greenhouse effect explains the heating or the cooling of the Earth in a sense. So the atmosphere is what keeps our Earth warm. It's what makes it habitable for us. Without the atmosphere, the Earth would be cold like the moon. And how it works is when the sun's energy comes down to Earth, it radiates back, and some of the energy goes back out into space, but some of it reflects back down and it gets trapped in that atmosphere. And that's called the greenhouse effect. And what the atmosphere is made up of are called greenhouse gases, such as carbon dioxide. So carbon dioxide with other greenhouse gases in the atmosphere will increase the atmosphere's ability to keep that energy, that heat, or that warmth in the atmosphere and prevent it from going back out into space. So you can think of the atmosphere kind of like the windows in a car. If you leave your windows rolled up in your car and leave it in the sun, it's going to be really hot when you go back to get back into your car. So your windows are kind of like the greenhouse gases, but if you roll them down, there's more space for that energy to get out of your car, and it's not as hot, right? So there are things that can contribute to the levels of greenhouse gases on Earth. So things that humans do, such as agriculture, like the agriculture of cows produce a lot of methane. That's a greenhouse gas. And then using fossil fuels for things like our industry and travel, our cars, planes, produces a lot of carbon dioxide. But then, oh, hey, what's this? This is actually a natural cause, right? So natural causes can produce greenhouse gases as well that get up into the atmosphere and can change the Earth's ability to maintain or lose heat, right? So gases and CO2 in particular are directly correlated, or they're directly related to temperature. So you can see on this graph, this is thousands of years before present. So if this is today, this is 50,000 years ago, 100,000 years ago, 400,000 years ago. So this is a lot of data, right? So we can see dating back 400,000 years ago, carbon dioxide is really closely related to temperature, right? So as we saw about 350, 300,000 years ago, there was an increase of carbon dioxide in the atmosphere and the temperature increased, right? And it happened again 250,000 years ago, an increase of carbon dioxide, temperature increased. So what do we see happening today? This is, maybe 2,000 years ago or so, around the time of the Industrial Revolution, when we were burning a lot of fossil fuels, we saw an increase of carbon dioxide in the atmosphere, right? So of course, we have a rise in temperature. But what's different about today versus any other time is that look how high that carbon dioxide has gotten, right? Never before, you can see it's never gotten above 300 parts per million, right? And now it's over 350. So this is why we say that man-made causes are contributing to climate change, because our temperature is predicted to continue to increase with direct increase of carbon dioxide released by human activity into the atmosphere. So you may be wondering, are all ecosystems affected the same by climate change? Is Hawaii affected the same as Alaska, as Africa, as Europe, as Australia? And the answer is no, we don't think so. So this was some climate data taken up at Hakalau Forest National Wildlife Refuge on the side of Mauna Kea. And so we saw at high elevation up by Hakalau, the temperature was increasing faster than it was at low elevation stations. The temperature wasn't increasing the same. So how might climate change affect you? So as you may have heard, climate change is attributed to superstorms and intense weather events, right? So at the onset of climate change, we're seeing rising sea levels as our glaciers melt. We're seeing hotter and drier weather. We're seeing increased fires with hotter and drier weather. We're seeing severe storms such as hurricanes, loss of native habitat, including glaciers and sea ice. So what can we do to help manage these environmental threats, whether it's climate change or invasive species or pollution? What can we do on an everyday basis? What can we do as scientists? What can we do to help? So in the past and today, a few things that we are doing here in Hawaii specifically is we're managing invasive species, right? So you can see in this picture, in this fence, this is the side where pigs live, and this is the side where pigs are fenced out. And the reason we fence out pigs is illustrated very well in this picture, because they really destroy a lot of the native vegetation. So we keep some space for the pigs, and then we fence them out and keep some space for the native forest so it can continue to generate clean water for us through our watersheds. And then we also go in and remove invasive species like this ginger by hand, using herbicide, using machines, and then planting native species in their place, right? Reduce fire risk, whether that's through outreach and education to inform folks not to throw cigarette butts outside, not to park hot cars over dry grass. And then we can restore our native habitat, right? Planting native trees And this is a picture of the alala. They did a capture and release program with the alala at Pu'umaka'ala, trying to get their population back up. Natural resource monitoring, so collecting data about our natural ecosystems to understand them better and understand how we can help them better. And then public access, education, and outreach, getting people to these beautiful places, making sure the public cares about our natural resources, because if we don't care about our environment, the government is not going to spend money on caring for the environment. So phenology data is another way that we can use to learn more about climate change. Oh, but wait, you might be wondering, what is phenology? So phenology is the study of plant and animal life cycles related to seasonal changes in climate. So these are events like flowers blooming, fruit being available, migrating, having babies. Those are all plant and animal life cycles that are related to climate. For example, when we see whales migrate to Hawaii in the winter, they're coming down here for warmer weather and food. We see kolea migrating to Hawaii, and then they fly back up to Alaska. And then when we see lychee fruit during the summertime, these are all examples of phenology. And they're all dependent on the climate and the whatever season it is. So here's a close-up of some ʻōhiʻa phenology. We can have phenology of our leaves and phenology of our fruit and flowers, right? So a quick snapshot of our leaf phenology. They first start as a bud, and then it breaks into a breaking leaf bud. And then a young leaf, or liko, is this fuzzy light green layer. And then these darker green leaves are what they turn into. Similar with our fruit and flowers and seeds. It starts out as a flower bud, turns into an open flower, and then turns into a fruit. So plants and birds and animals use environmental cues such as sunlight, temperature, and rainfall to know when to bloom, mate, and migrate. So the whales that are coming to Hawaii, they don't have a calendar or a clock to remind them when to go. The same thing with our fruits and flowers. They don't have a calendar or a reminder to tell them when to blossom or when to fruit. They're taking in those seasonal cues. So when the seasons change and the climate is changing seasonally, our amount of sunlight might change, the amount of rainfall, the temperature. All of those are the cues that plants and animals take to know when to start their next life cycle event, or phenophase. So we see phenology as a very important component of Hawaiian culture, and just a way of knowing what's going on in your environment and using that as important knowledge for decision making. So for example, we see in Olelo No'eau some important proverbs that helped people look to things on the land and make decisions or have knowledge about what's going on in the sea. So this is a pretty popular one. Na pua wili wili, na nahu ka mano, when the wili wili tree blooms, the sharks bite. So when the wili wili tree blooms right about now in the fall, around October, the sharks bite. And that's because right now it's just around mating season for the sharks. And they're gonna be closer to shore and more aggressive than usual. Pala ka hala, momona ka ha uke uke. When the hala is ripe, the ha uke uke is fat and ready to eat. So you know when the hala is fruiting and it's ripe, you know there's a lot of uke uke, or sea urchins in the ocean, ready to harvest. Puake ko kumai ka he'e. When the sugarcane flower, the he'e, are present. So the same thing, same time of year the sugarcane are flowering is a good time to go fishing for he'e or octopus. So now that we're a little bit more familiar with phenology, let's get really familiar with ʻōhiʻa phenology. So this is the ʻōpuʻu lehua, or the flower buds. This is the very first phenophase of ʻōhiʻa flowers. And then more ʻōpuʻu lehua, they can be different colors, green, orange, yellow. What you're really looking for is that circular cluster of flower buds. And then this is called mohala, or blooming. You can see the petals are starting to come out of the flower bud to form a flower, such as this, the lehua, or the flower. Lehua. And then there's quite a few on here. We see lehua, mohala. So this is our lehua, mohala, and the ʻōpuʻu lehua. We have a few here too. The ʻōpuʻu lehua, the lehua. And this one is called kukuna, which means like ray. So this is when all the stamen of the flower fall off and only these pistils remain, and it's getting ready to fruit. Another kukuna. And then this is the hua, the fruit. So after those pistils fall off, what's left underneath is the fruit, the hua. More hua. So after it's done fruiting, we have the seeds, or the ano. More ano. They're very tiny, like the size of your fingernail. And then after it's done seeding, all the seeds have been blown away by the wind into new ʻōhiʻa trees. We have the hua haka, the empty seed pots. In this picture, we have quite a few. We have the lehua, ʻōpuʻu lehua, kukuna, ʻōpuʻu lehua, hua haka, many. Now that you're an expert at phenology, you can create your own olelo noʻeau about phenology. A few examples are, on Oahu in the summer, I surf the North Shore because the waves are big. In the spring and early fall, I harvest and eat breadfruit. During the winter in Hilo, I hibernate watching Netflix because the rain is so frequent and chilly. Now you try. Thank you for tuning in. Again, my name is Blair with Teaching Change, and this has been a presentation on climate change and phenology. Aloha.